Welcome to Journey into Insight. Close your eyes for a moment and imagine the night sky. A vast ocean of glittering stars, stretching endlessly in all directions. Every point of light you see, every sun, planet, and galaxy, feels infinite. Yet here's the astonishing truth. Everything your eyes can witness, everything ever captured by a telescope, everything that makes up the cosmos you think you know, is less than 5% of reality. The rest, the remaining 95%, is invisible. We can't touch it, we can't see it, we can't even feel it. But it's there, shaping every movement of the universe, dictating its past, its future, and our very existence. This is the unseen world, the silent symphony of dark matter and dark energy, two mysterious forces that dominate the cosmos, yet refuse to reveal their faces. Our journey begins with a question as old as curiosity itself. Why doesn't the universe behave the way it should? When astronomers first studied galaxies spinning in space, they expected the outer stars to slow down, just like the outer horses on a carousel take longer to circle than those near the center. But that didn't happen. Instead, every star, near or far, moved at almost the same speed, as if some invisible hand was holding the galaxy together. The laws of gravity weren't enough to explain it. Something else, unseen and unknown, had to be there. A vast halo of invisible mass surrounding every galaxy, keeping it intact. That unseen mass became known as dark matter. The idea wasn't new. In the 1930s, a bold astronomer named Fritz Zwicky noticed galaxies in a cluster moving far too quickly. They should have torn apart long ago, yet they didn't. He suspected there was more mass there than the eye could see, and he called it dunkle materie, dark matter. Decades later, Vera Rubin, one of the most brilliant astronomers of her time, confirmed it. She mapped the rotation of galaxies and found the same mystery Zwicky did. The stars at the edge were moving too fast. The visible matter, stars, dust, gas, wasn't enough. The universe, it turned out, was haunted by an invisible presence. Not ghosts, but gravity, unseen, powerful everywhere. If you could see dark matter, you wouldn't recognize the universe. Galaxies wouldn't look like isolated islands of light. Instead, you would see them connected by invisible filaments, vast cosmic highways of dark matter stretching across billions of light years. Astronomers call it the cosmic web, the true skeleton of the universe. Every galaxy, every cluster sits where these filaments intersect, like dewdrops on an endless spider's web. Ordinary matter, the stuff that makes stars and planets, simply gathered where dark matter had already laid the foundation. In other words, dark matter isn't a background detail. It's the architecture of existence. Without it, galaxies would never have formed. The Milky Way itself, the home of our sun and all the stars we see, is only here because an invisible scaffold holds it together. But if we can't see it, how do we know it's really there? The universe offers clues for those who know where to look. One of them is called gravitational lensing, a trick of light that reveals invisible mass. When light from a distant galaxy passes near a massive object, its path bends as if space itself were warped. The more mass, the more the light bends. And when scientists map these distortions, they find that most of the mass causing the bending isn't visible. It's dark matter, silent, unseen, but undeniably there. It is like watching shadows move across a wall and realizing something invisible is dancing just beyond the curtain. Yet even as we map this hidden framework, another mystery emerges, one even stranger and more powerful. In the late 1990s, two teams of astronomers studying distant supernovae expected to find that the universe's expansion was slowing down. Gravity, after all, should be pulling everything inward over time. But what they found was shocking. The expansion wasn't slowing, it was accelerating. The universe was speeding up, as if pushed by a force stronger than gravity itself. That force is what we now call dark energy. Think of dark energy as the opposite of dark matter. If dark matter is the cosmic glue holding galaxies together, dark energy is the invisible wind pushing them apart. It doesn't pull, it pushes. It stretches space itself, Every second, the fabric of the cosmos expands a little more, carrying galaxies farther and farther apart. Right now, dark energy makes up about 68% of everything. Dark matter adds another 27%. That leaves less than 5% for everything else. The stars, the planets, the people, the history of life itself. We are living in a universe made mostly of things we cannot see or touch. It's humbling, isn't it? To realize that the visible world, everything that feels real to us, is just the tip of a cosmic iceberg. Beneath it lies an unseen ocean, vast and deep. Some scientists believe dark energy is a property of space itself, a kind of energy that fills every cubic centimeter of the universe, even the emptiest void. Others suspect it could be something dynamic, a field that changes over time, perhaps linked to the strange world of quantum mechanics. Einstein once introduced a concept called the cosmological constant, a mathematical term representing a force that could oppose gravity. He abandoned it, calling it his greatest mistake. But after the discovery of dark energy, that mistake might have been one of his most prophetic ideas. The balance between dark matter and dark energy shapes the destiny of everything. If dark energy continues to accelerate the universe's expansion, galaxies will drift farther apart until their light can no longer reach one another. Billions of years from now, future observers, if any remain, may see only their own galaxy in a dark, empty sky. The rest of the cosmos will fade beyond visibility, leaving an illusion that the universe has shrunk, even as it endlessly expands. But if dark energy weakens, gravity might win the cosmic tug-of-war, pulling everything back together in a final fiery collapse, a reverse Big Bang known as the Big Crunch. Between these two extremes lies our fragile moment, a temporary equilibrium that allows galaxies, stars, and life to exist at all. To imagine these invisible forces, think of a grand orchestra. Dark matter is the rhythm, steady, holding everything in harmony. Dark energy is the melody, expansive, sweeping, unpredictable, and the visible universe, the stars and planets, are just the instruments playing their part. We hear the music, but the rhythm and melody that give it meaning are hidden from sight. Even here on Earth, our existence depends on this invisible balance. Without dark matter's gravitational pull, our galaxy would disintegrate. The sun might wander alone through space, and Earth, along with every spark of life, would be lost. Without dark energy, the universe might have collapsed long ago under its own weight. We are here because two unseen forces have kept the cosmic dance in motion for billions of years. Every atom in your body, every thought in your mind exists within this delicate balance between the pull of dark matter and the push of dark energy. Scientists across the world are chasing these mysteries with relentless determination. Deep underground, in silent laboratories shielded from cosmic radiation, detectors wait patiently for a passing particle of dark matter, one that might collide with an atomic nucleus, releasing a whisper of energy. Space telescopes like the European Space Agency, Euclid and NASA, James Webb are mapping the shapes of galaxies across billions of light-years to trace the fingerprints of dark energy. Particle accelerators like CERN's Large Hadron Collider smash subatomic particles together, hoping to glimpse new physics that could explain both mysteries. So far, the answers remain hidden. But each experiment brings us a little closer to seeing the invisible. And yet, there's a strange beauty in not knowing. The fact that 95% of the universe is still a mystery isn't a failure of science, it is an invitation to wonder. It reminds us that reality is larger than imagination. It reminds us that despite our technology and intelligence, we are still explorers standing on the edge of an unfathomable ocean, gazing into the dark. For all our progress, the universe still holds secrets beyond comprehension, and that's what makes it beautiful. When you stand beneath the night sky and look up at the stars, remember this: you are seeing just the surface of something far greater. The Milky Way glowing softly above you is wrapped in an invisible halo of dark matter. Every galaxy you glimpse through a telescope is part of an unseen web stretching across the cosmos. And beyond that web, dark energy hums, an invisible tide pushing space apart, carrying the future with it. The stars may seem eternal, but the universe itself is still unfolding, reshaping and reinventing itself in ways we can barely grasp. We humans, tiny and fragile, have found a way to ask the grandest questions imaginable. What is the universe made of? Why does it exist? What forces govern its fate? These are not questions of science alone. They are questions of meaning, of curiosity, of awe. Perhaps dark matter and dark energy are not just physical mysteries, but mirrors reflecting our hunger to understand. We see darkness not as emptiness, but as potential, the space where discovery begins. Maybe one day we'll uncover the true nature of these invisible forces. Maybe we'll find that dark matter is made of exotic particles drifting through us every second, unseen yet constant. Or maybe we'll discover that dark energy isn't a thing at all, but the whisper of something deeper, the pulse of space-time itself. Until that day, we will keep searching, because curiosity is the force that makes us human. It's our own kind of dark energy, invisible, unstoppable, and always expanding. So when you gaze up tonight, let wonder take over. The light from those stars has traveled for millions of years just to reach your eyes, threading through a universe held together by unseen hands. We live inside a mystery so vast that even the word infinite feels too small. And that's the beauty of it. The darkness between the stars isn't emptiness. It's full of the unknown, full of possibilities, full of the quiet hum of creation itself. The universe is not a riddle to be solved once and for all. It is a story, unfolding chapter by chapter, written in light and shadow. Dark matter and dark energy are simply the latest pages we've begun to read. The rest is still waiting, somewhere beyond the edge of sight, calling us to look deeper, to reach farther, and to keep asking why. And that, my friend, is what makes the cosmos so endlessly fascinating. Not just what we know, but what we don't. The mystery isn't a wall, it's a door, and through that door lies everything we've yet to imagine.